Dear friends, in this episode we are going to learn about structure of atom. Structure of atom is an important chapter in class 11th chemistry. Atomic theory of matter. According to this theory, atom is the ultimate particle of matter. This atomic theory of matter is also known as Dalton atomic theory and it is given in 1808. Cathode ray discharge tube experiment. According to this experiment, cathode rays start from cathode and move towards anode. These rays are not visible, but their behavior can be observed with fluorescent and phosphorescent material. In the absence of magnetic field and electric field, these rays traveled in straight line. In the presence of magnetic or electric field, the behavior of cathode rays is similar to negatively charged particles, which suggests that these rays contain negatively charged particles called electrons. Cathode rays or electrons do not depend on the material of the electrode and nature of the gas in the tube. So electrons are the basic constituent of all atoms. Charge to mass ratio of electron. Charge to mass ratio of electron is measured by J. Thomson in 1897 by using cathode ray tube. By applying electric and magnetic field perpendicular to each other and also perpendicular to the path of electrons. He proposed behavior of particles from their path in the presence of magnetic or electric field depend upon the following, that is, magnitude of negatively charged on particle and mass of particles and strength of magnetic or electric field. So first is magnitude of negative charge on particle, that is, if magnitude of charge on particles is greater than interaction with magnetic or electric field is greater, so deflection is also greater. Mass of particle, that is, if particle is lighter, then diffraction is greater. Third, strength of magnetic and electric field, that is, if strength of magnetic field or voltage at electron is increases, then deflection of electron also increases. Value of E by me, that is charge to mass ratio, is equal to 1.758820 into 10 to the power 11 C per kg, that is coulomb per kg. Charge of electron. Charge of electron is determined by R.A. Millikan by oil drop experiment in 1906 to 1914. Charge on electron is equal to minus 1.6 into 10 to the power minus 19 coulomb. Present accepted value of electronic charge of electron is equal to 1.6022 into 10 to the power minus 19 coulomb. Mass of electron. From charge on electron and E by me, we get me is equal to E by divided by E by me. So me is equal to, that is mass of electron is equal to 9.1094 into 10 to the power minus 31 kg. I repeat, mass of electron is equal to 9.1094 into 10 to the power minus 31 kg. Discovery of protons. Protons are discovered by E. Goldstein. In modified cathode ray tube gives positive charge carrying particles known as canal rays. Lightest and smallest positive ion obtained from hydrogen called proton. Characteristics depend on nature of gas present in cathode ray tube, that is characteristics of protons. Charge to mass ratio of particles depend on gas from which these originate. Some of positive charge particles carry a multiple unit of electrical charge. Behavior of proton in magnetic or electric field is opposite to that of electron behavior. Discovery of neutron. Discovery of neutron is done by Chadwick in 1932 by bombarding a thin sheet of beryllium by alpha particles. Electrically neutral particles were emitted known as neutrons. Thomson model of atom. Thomson model of atom is given by J.J. Thomson in 1898. According to J.J. Thomson, atoms possess a spherical shape with radius about 10 to power minus 10 meter, in which positive charge is uniformly distributed. Electrons are embedded in such a manner to give most stable electrostatic arrangement. Other names of this model are as follows: plum pudding, raisin pudding, watermelon model. Mass is assumed to be uniformly distributed in atom. Rutherford's nuclear model of atom. Rutherford nuclear model of atom is given by Rutherford and his students Ernest and Hensberg by alpha particle scattering experiment. When beam of high energy alpha particles was directed at gold foil, then tiny flash of light observed at photographic plate. Rutherford observed that mass of alpha particle passes through gold foil undeflected. Most of alpha particle passes through gold foil undeflected. Second, a small fraction of alpha particles was deflected by small angles. A very few alpha particles, about 1 in 20,000, bounced back, means deflected by nearly 180 degrees. From above observation, he concluded the structure of atom as, that is, first, most of space in atom is empty because most of alpha particle passes undeflected. Few positively charged alpha particles were deflected because positive charge of atoms present in center in very small volume that repelled and deflected the positive charge alpha particles. Volume of nucleus is negligible as compared to total volume of atom, that is, radius of atom is equal to 10 to power minus 10 meter approx, and that is of radius of nucleus is equal to 10 to power minus 15 meter approx. On the basis of observation and conclusion, Rutherford proposed model of atom as positive charge and most of the mass present in the center of atom known as nucleus. Electrons move around nucleus with very high speed in circular paths known as orbits. Electrons and nucleus, that is protons, are held together by electrostatic force of attraction. Atomic number Z is equal to number of protons in the nucleus of an atom is equal to number of electrons in a neutral atom. Mass number A is equal to number of protons plus number of neutrons. Isobars, these are atoms with same mass number but different atomic number. Example, carbon 14 and nitrogen 14. Isotopes, these are atoms with same atomic number but different atomic mass number. Example, protium, deuterium, tritium, etc. Wave nature of electromagnetic radiations. First explained by James Maxwell in 1870. Oscillating magnetic and electric field produced by the oscillating charged particles are perpendicular to each other and also perpendicular to the wave direction of propagation. These waves do not require medium, that is, electromagnetic waves can travel in vacuum. Electromagnetic radiation differ from one another in frequency or wavelength, gives electromagnetic spectrum. Different units are used to represent electromagnetic radiations. Particle nature of electromagnetic radiations, also known as Planck's quantum theory. Planck suggests that the atoms and molecules can absorb or emit energy in discrete quantities, not in continuous manner. Planck gave it name as quantum. Energy of quantum of radiation is directly proportional to its frequency, that is E is equal to Hn, where H is equal to Planck's constant, is equal to 6.626 into 10 to the power minus 34 Js joule second. Photoelectric effect. Photoelectric effect is given by as Hertz in 1887. When a beam of light strikes a metal surface, then electrons were ejected. This phenomena is known as photoelectric effect. Electron ejected from metal surface when beam of light strikes metal surface. Number of electrons ejected is directly proportional to intensity brightness of light. There is characteristic minimum frequency N0 threshold frequency below which photoelectric effect is not observed. If N, that is frequency, is greater than N0, that is threshold frequency, then electrons comes out with kinetic energy, which increases with increase in frequency of light. Kinetic energy of ejected electrons is given by Hn is equal to Hn0 plus 1 by 2 MeV square. Spectroscopy. Spectroscopy is the study of absorption or emission spectra. Bohr model for hydrogen atom. Bohr model for hydrogen atom is explained by Niels Bohr in 1913. Postulate for Bohr model are as follows. First, electrons in hydrogen atom move around nucleus in circular path of fixed radius and energy. These paths are called orbits. Energy of electron does not change with time. However, when electrons move from lower to higher stationary state, it absorbs some amount of energy and energy released when it comes back. Frequency of radiation emitted or absorbed when transition of electrons occur is given by frequency nu is equal to del E by H is equal to E2 minus E1 by H, where E1 and E2 is lower and higher energy state. Angular momentum of an electron in given stationary state is given by MEVR is equal to N into H by 2 pi, where N is equal to 1, 2, 3. Limitation of Bohr model. Bohr model failed to explain fine details of hydrogen atom spectrum observed by spectroscopic techniques. It also failed to explain spectrum of other atoms except hydrogen atom. It also failed to explain splitting of spectral lines in presence of electric field, that is Stark effect, or magnetic field, that is Zeeman effect. It also failed to explain formation of molecules from atoms by chemical bonding. Dual behavior of matter. Dual behavior of matter is explained by de Broglie in 1924. He explained that matter also behave like radiation and exhibit dual behavior, means both like particle and wave like properties. Sorry, relation. Wavelength is equal to h by mv, where h is Planck's constant, m is mass of particle, v is velocity of particle, also equal to h by p, where p is momentum. Hensberg uncertainty principle. Hensberg uncertainty principle is given by Werner Hensberg in 1927. He explains that it is impossible to determine simultaneously the exact position and exact momentum or velocity of an electron. Quantum mechanical model of atom. Branches of science which explain dual behavior of matter is called quantum mechanics. Quantum mechanics, independently developed by Werner Heisenberg and Erwin Schrödinger in 1926. Fundamental equation developed by Schrödinger. He won Nobel Prize in 1933. Equation for a system, atom or molecule was energy does not change with time. Principal quantum number n. It is a positive integer with value of n is equal to 1 to 3. It determines size and energy of orbital. It also identifies the cell with increase in number of allowed orbitals and given by n square. N is equal to 1, 2, 3, 4 and so on, and cell is equal to KLM so on. KLM L so on, and size of orbital increases with increase in n. Azimuthal quantum number L. It is also known as orbital angular momentum or subsidiary quantum number. It defines 3D shape of orbital for given value of n possible values of L is equal to 0, 1, 2, 3, 4, 5 and so on n minus 1. Example, if n is equal to 1, then L is equal to 0. If n is equal to 2, then L is equal to 0, 1. If n is equal to 5, then L is equal to 0, 1, 2, 3, 4. Each cell consists of one or more subcells. Number of subcells is equal to value of n. If n is equal to 1, then 1 subcell. If n is equal to 2, then 2 subcell. If n is equal to 3, then 3 subcell. Magnetic orbital quantum number Mi. This quantum number Mi gives information about orientation of the orbital. Mi is equal to 2L plus 1. That is, if value of L is 1, then value of Mi is equal to 2 into 1 plus 1 is equal to 3. That is minus 1, 0, plus 1. Electron spin quantum number Ms, proposed by G. Uhlenbeck and S. Goldsmith in 1925. Electrons spin around its own axis. Ms have two values, plus half and minus half. Ms gives information about orientation of the spin of the electron. Above principle. According to this principle, in the ground state of the atom, the orbitals are filled in order of their increasing energies. Means electrons enter higher energy orbitals, so order in which orbitals are filled is as follows: 1s, 2s, 2p, 3s, 3p, 4s, 3d, 4p, 5s, 4d, 5p, 6s, 4f, 5d, 6p, 7s, 5f, 6d, 7p. Pauli exclusion principle. Pauli exclusion principle is given by W. Pauli in 1926. Two electrons in an atom can't have same set of 4 quantum number. Only two electrons may exist in same orbital, and these electrons must have opposite spin. Hund's rule of maximum multiplicity. According to this rule, pairing of electron in an orbital belonging to the same subcell as p, d or f does not take place until each orbital belonging to that subcell has got one electron each, that is, it is singly occupied. You can download PDF notes of this chapter from our website www.chemistrynotesinfo.com. Do follow us to get more science videos, more science podcasts, and learn chemistry with us. Thank you to listening this podcast.